Law of constant proportions or law of definite proportion. Now, we know that a compound, okay, is formed of more than one element. So let me call it element 1 and element 2. Okay. What this law of constant proportions says is, now obviously if there are two things, the concept of proportion can come in where it can come only in the case of elements, because the compound is going to have a given mass, right? So what the law of constant proportion says is that if you have a compound which is formed, okay, then the proportion of the mass of the various elements which are there in this compound is constant. Now what do I mean by this? So let me take a particular example. We have a compound which is, let's say the simplest one is water. Okay. Now water consists of two elements, okay, if I may call them. One is hydrogen and second is oxygen. Right? Now what this law of constant proportion says is that it is a proven law that whenever you consider H2O or water, okay, it can be formed only from a set of common elements, which is hydrogen and oxygen. You cannot take carbon and form water, right? So there's a compound of water that has to comprise of hydrogen and oxygen. So the elements which form a compound are constant, right? They're the same. And the second thing is that the mass of these two compounds is always in a definite proportion, right? So if we talk about water, in this case, the proportion of mass is 1:8, right? So 1:8. So 1 mass of hydrogen and 8 mass of oxygen. Now you can take any of the quantum of water. So let's say if you take 100 ml, okay, or let's say 100 grams of water, or you may take 1000, you may take 5000, or whatever number you want to take. If you pass on electricity and decompose this water into hydrogen and oxygen, then the proportion of the mass of hydrogen and oxygen in this decomposition is going to remain at 11 and 89, because the ratio is 1:8. Okay, we've just kind of rounded off this. If you talk about 1000 again, the ratio is going to be 110 and 8. Actually, to be precise, it might be 888 over here and 112. Right? Similarly, I mean, if you see the ratio, these are the absolute number, the ratio is going to be 1:8. This is again 1:8, roughly. Similarly, for 5000 also, you divide it by 9, okay? So you will get 555 over here, right? And 600, 4, 444, 5 over here. So the mass is always going to remain in constant proportion. The proportion of hydrogen and oxygen by mass will not change. Now this water we are talking about, you may obtain it from any of the sources, as long as it is water, right? So you may have the distilled water, maybe, right? You may have sea water, you may take it from any pond or something, but whenever you disintegrate it, okay, by applying electricity or decompose it actually, then this proportion of mass is going to remain constant. Similarly, this was a case of an example of water. Let me give you another example. If you break ammonia, okay, this is going to give you nitrogen and hydrogen, right? The ratio of nitrogen and hydrogen is going to be 14:3 by mass, right? So if you take this, let's say 100 grams, Nitrogen is going to be 100 into 14 divided by 17, and hydrogen is going to be 100 into 3 divided by 17. If you take 500, right, it is going to be 500 into 14 by 17. This will be 500 into 3 by 17, right? Roughly around 83 and 17. So basically the mass of these two, the proportion of mass of these two, right, is going to be always remain the same. Or maybe I should use the word constant. That's what the law of constant proportion says. To recapitulate, two things. One, in any given compound, the elements which can be used to form that compound remain the same, right? Second, the mass of each of these elements is in a defined proportion to each other. For any given quantity of the compound, the proportion of the mass of elements is going to be always a constant.